Good morning all. In this lecture, I am discussing about the image sensing and acquisition. Okay, if you are taking any image in two-dimensional, that is a function of x comma y. Okay, the image is a function of x comma y. Those x comma y are called spatial coordinates. Okay, in this, if you are taking monochrome image or color image, including the frequency, the three basic quantities are used to describe the quality of a chromatic light source. Okay, three basic quantities are used. If you are taking the three basic quantities are radiance, illuminance, and brightness. Radiance, illuminance, and brightness. Radiance means total amount of energy that flows from the light source. That flows from the light source. Okay, so you are taking the radiance. The radiance is defined as the total amount of energy that flows from the light source. That flows from the light source. That is measured in watts. That is a radiance. The next quantity is luminance. Luminance. What is meant by luminance? Means the measure of the amount of energy an observer perceives from light source, measured by the luminance. Okay. So here luminance means a measure of the amount of energy an observer perceives from light source measured by the luminance. That is the luminance. That means how much perceived from the light source. The observer, how much perceived from the light source. That will be the luminance. If you are taking the next quantity as brightness. Brightness means it is a subjective descriptor of the light perception. Okay, it is impossible to measure. If you are taking the brightness, that is only practically impossible to measure. Okay, so the three quantities are radiance, that is the total amount of energy that flows from the light source, that is measured in watts. Okay, luminance. Luminance means a measure of the amount of energy an observer perceives from light source. How much light source will be perceived by the observer? That will be the luminance. That will be measured in lumens. Next, next brightness. Brightness means it is a subjective descriptor of light perception. Subjective descriptor of light perception. That is practically impossible to measure. There is no units for brightness. Okay, in this image sensing and acquisition, the types of images in which we are interested are generated by the combination of an illumination source and the reflection or absorption of energy from that source by the elements of the scene being imaged. Okay, so here in image sensing, the types of images in which we are interested are generated by the combination of an illumination source and the reflection or absorption of energy from that source by the elements of the scene being imaged. Okay, so here the image is represented as function of x comma y, that is function of the spatial coordinates is equal to I of x comma y by r of x comma y. If you are taking this illumination I of x comma y, this illumination range is from 0 to infinity, and this r of x comma y is a reflection. This reflection is ranges from 0 to 1. Okay, so if you are taking we are taking this, f of x comma y is I of x comma y by r of x comma y. So this r of x comma y ranges from 0 to 1. Okay. Here we are taking most of the images, those will be generated from the combination of an illumination source and the reflection or absorption of the energy from that source. Okay. If you are taking, depending on the nature of source, illumination energy is reflected from or transmitted through objects. Okay. Depending on the nature of source, depending on the nature of source, illumination energy is reflected from or transmitted through objects. Okay. The illumination energy is reflected from or transmitted through objects. So if you are taking the below figure, this figure shows the three principal sensor arrangements used to transform illumination energy into digital images. Illumination energy into digital images. In this, if you are taking the idea here, incoming energy is transformed. Incoming energy is transformed into a voltage by the combination of input electrical power and sensor material that is responsive to the particular type of energy being detected. Okay, this diagram, in this diagram, the idea is here, incoming energy is transformed into a voltage by the combination of input electrical power and sensing material that is responsive to the particular type of energy being, this is a particular type of energy being detected. Okay, the output voltage waveform, this is the output voltage waveform, is the response of the sensor, response of the sensor, and the digital quantity is obtained from each sensor by digitizing its response, by digitizing its response. Okay, so this is the line sensor. In this is the line sensor, and this is the array sensor. Array sensor like a matrix. Okay, so this is a single imaging sensor. This is a single imaging sensor. This is a line sensor, and this is a array sensor. By using the sensor, the capturing the image will be occurred. Capturing in the sense acquire the image. Acquire the image. So here, if you are taking image acquisition using a single sensor, image acquisition using a single sensor. In this is the field, and this in this way rotation will be occurred. Suppose if this is a linear motion, so one image by using this sensor, this image is captured. So the one image line out per increment of rotation and full linear displacement of sensor from left to right. Full linear displacement. Linear displacement, that is from left to right. If we observe this figure, the components of a single sensor, perhaps the most familiar sensor of this types is photodiode. Generally, we are using photodiodes. which is constructed of, that is constructed of silicon materials. Silicon materials. If you are taking the use of a filter in front of the sensor, the use of a filter in front of the sensor improves selectivity. Okay. So if you are using the filter, suppose if any unwanted object will be entering, that will be filtered. Okay. In order to generate a two-dimensional image using a single sensor, there has been relatively displacements in both x and y directions between the sensor and area being imaged. Okay. This figure, this image acquisition using a single sensor. This is the sensor. Only one sensor is used here. So this figure shows is used in high precise scanning, where a film negative is mounted onto a drum whose mechanical rotation whose mechanical rotation provides displacement in one dimension. That means if this rotation is going on, then the linear motion is also progressive. Okay. So the single sensor is mounted on a lead screw that provides motion in the perpendicular direction. The motion in the perpendicular direction. Because why the perpendicular motion direction means that is because of the mechanical motion can be controlled with high precision. Mechanical motion can be controlled with high precision. Okay. The if you are taking other mechanical arrangements, these are used flat bed with the sensor moving in a two linear directions. Okay. Two linear directions. So if you are taking this diagram, totally we observe that by using this image acquisition, so if the rotation will be occurred, there is a linear motion will be occurred from left to right. Here we are using only one sensor. Okay. Next, if suppose image acquisition by using sensor strips. Sensor strips. Suppose if you are in this, how the image is acquired. That means here if we observe this diagram, the strip provides image elements in one direction. The strip provides image direction in one direction. Motion perpendicular to the strip. This is perpendicular direction. Perpendicular to the strip provides imaging in another direction shown in figure. Okay. This is a type of arrangement used in most flatbed sensors. Here we are using inline sensors. These are used routinely in airborne imaging applications, okay, in which the imaging system is mounted on an aircraft that flies at a constant altitude and speed over time geographical area to be measured. That means to be taking as an image. One-dimensional imaging sensor. Suppose if you are taking one-dimensional imaging sensor strips that respond to various bands of the electromagnetic spectrum are mounted perpendicular to the direction of flight. Perpendicular to the direction of flight. This is the image acquisition using sensor arrays. Okay. So suppose if this will be the image captured by this imaging system, so that will be appeared as an output image in a two-dimensional image. This is a two-dimensional image in a spatial coordinates. Okay, so here this figure shows individual sensors arranged in the form of a 20 array. Okay, and here electromagnetic and some ultrasonic sense devices frequently are arranged in an array formed. In this, we are using a typical sensors for these cameras is a charge coupled devices array. Charge coupled devices array. The response, suppose if you are taking the sensor, the response of each sensor is proportional to the integral of the light energy projected onto the surface of the sensor. Projected onto the surface of the sensor. This property is used in astronomical and other applications also, having low noise images. Where the low noise images, in that case we are using this image acquisition using sensor arrays. In here, the first function performed by the imaging system is here. This will be this is used to collect the incoming energy and focus it onto a image plane. This is a image plane. If the illumination is light, then the front end of the imaging system is an optical lens. Here we are using an optical lens that projects the video scene onto the lens focal plane. Here the sensor array, this is coincident with the focal plane that produces outputs proportional to the integration of lights received at each sensor. Okay, proportional to the light, integral of light at each sensor. Here, digital and analog circuitry sweep these outputs and convert them into an analog signal. Converted them on analog signal. That analog signal, which is then digitized by an other section of the imaging system. See here, this will be numerous electromagnetic and ultrasonic sensing devices arranged in array format. Here, if you are taking the sensor, this will be CCD array is here taking as 4000 by 4000 elements or more. Here, CCD means charge coupled devices. Okay, charge coupled devices. Here, response of each sensor. Response of each sensor is proportional to the integral of the light energy projected on the surface of the sensor. It is two-dimensional. Okay, integration of input light reduces the noise, which is unwanted in that image. The advantage is usually the complete image can be obtained by focusing the energy pattern onto the surface of the array. So here you are getting totally complete pattern of the image in this. Here, complete image can be obtained by focusing the energy pattern onto the surface of the array. Here, if you are taking linear sensor strip, circular sensor strip. Linear sensor strip means that uses in flatbed scanners. Circular sensor strip means mounted in a ring configure. So here the devices are 4000. This circular sensor strip use medical and industrial. Yeah, if you are taking applications, airborne imaging, aircraft. In aircraft, these linear sensor strips are used. This circular sensor strip means that is used to get 3D objects, 3D, 3-dimensional objects. If you are taking linear sensor strip, that gives one line of image at a time and completes 2D, 2-dimensional image. Okay, gives one line of image at a time and completes a 2-dimensional image. Okay, here this reconstruct in circular sensor strip transforms sensed data into cross-section image. So these are the points in linear sensor strip and circular sensor strip. Okay, so if you are taking any simple image, the formation model is illumination and reflectance. Components, illumination means that will be represented as I of x comma y. Reflectance, this will be represented as r of x comma y. So if you are taking any image that is a function of f of x comma y is equal to, that is having both the illumination and reflectance. Illumination and reflectance. Okay, if we are taking the illumination, that will be range from 0 to infinity. The illumination range is from 0 to infinity, and the reflectance range is in between 0 and 1. The reflectance range is in between 0 and 1. Okay, here nature of f of xy. Suppose if you are taking this f of xy as an image point, 1 pixel, then the amount of source light incident on the scene being viewed. Okay, the amount of light reflected by the objects in the scene. Here, illumination and reflectance components. So those will be represented as I of x comma y. Illumination, reflectance is represented as r of x comma y. Here, the illumination range is in between 0 and infinity, and the reflectance range is in between 0 and 1. So in this way, the image representation will be there. These are different pixels. These are different pixels. 1 point is 1 pixel in that image. The values of the coordinates at the origin. This, if this is the origin, the values are 0, 0. Okay. The next coordinate values along the first row of the image are represented as 0, 1. 0, 1. Here 0, 1, like that. The notation 0, 1 is used. That 0, 1 is used to signify the second sample along the first row. Okay. So here in this image acquisition, image sensing and acquisition, here we are using to capture the images. Capturing the image is the acquisition. How to sense, how to capture the image by using the cameras and all, means by using the sensors only captures the images. Okay, so in this we are using a totally image acquisition using a single sensor and image acquisition using the sensor strips and image acquisition using sensor arrays. These three models we learn in this. Suppose the first one, image acquisition using a single sensor. In this, we learn the single sensor is mounted on a lead screw that provides motion in the perpendicular direction. The motion will be in the perpendicular direction. That means if that will be rotated, then that will be linearly motion from left to right. Okay, that will be based on that. If you are taking some mechanical arrangement, those will be used flatbed within the sensor moving in two linear directions. Okay, this is about the image acquisition using a single sensor. The next one is image acquisition using sensor strips. In this image acquisition, here we are taking the strip. The strip provides three parts. That will be first image acquisition using a linear sensor strip, and a cross-sectional images of. Okay, next here, this will be the image acquisition using a sensor strips, circular sensor strips. In this, we learn linear sensor strips and circular sensor strips also. So here, this strip provides imaging elements in only one direction. This provides imaging elements in one direction. That motion is also perpendicular to the strip, provides imaging in the other direction. Okay, actually this is the type of arrangement used in most flatbed scanners. Sensing devices with 4,000 or more inline servers are proceed. Okay, thank you.